Okay, so continuing on this one that we left off on, because 5 and 3 are both common factors of 60 and 45, when I multiply them, I get their greatest common factor. GCF is 15. And that's because, notice at the bottom, 4 and 3 don't have any common terms. Like, they don't have any common factors. So I know that this is as far as I can go. Okay, so let's try another one. Okay, so we're going to try 20 and 30. So I noticed that 20 and 30 end in a 0, which means they're both even numbers. And all even numbers are divisible by 2. So I'm going to write that over here on the side in case you've forgotten. Even numbers are divisible by 2. Okay, so so I can do 30 divided by 2, which is 15, and 20 divided by 2, which is 10. Notice I keep these numbers that I have divided directly underneath the previous number. So 15 times 2 is 30, 10 times 2 is 20. Okay. 10 and 15 both have a common factor, so I'm going to do a second rung. I know 10 ends in a 0 and 15 ends in a 5, which means they're both divisible by 5. Okay. So I do 15 divided by 5, which is 3, and 10 divided by 5, which is 2. Okay. Again, the common factor goes over here on the right, and these are just factors of the original 20 and 30. 2 and 3 are both prime numbers, and they don't have any common factors. So these numbers, when I multiply them together, should give me my greatest common factor. So then the GCF of 20 and 30 is 10. Okay, because 2 times 5 is 10. All right, I'm going to start a new page. All right, so for these ones, let's say that instead of just having two numbers, I had an expression that was 18 plus 30. But I still wanted to factor. I wanted to find the greatest common factor. I don't want to add them together. I want to find the greatest common factor that they have. So I'm going to set it up just like I did on the last one, but I'm going to keep the addition sign in between. So I write 18 plus 30, and then I'm going to do the ladder rung. Okay. A number that divides 18 that also divides 30. So I'm going to remember 18 and 30 are both even numbers, which means they're both going to be divisible by 2. And then I do 30 divided by 2, which is 15. And I do 18 divided by 2, which is 9. Okay, and then I look at 9 and 15. Do 9 and 15 have any common factors? Yeah, I know what their common factor is. 9 and 15 can both be divided by 3, so I put 3 on the outside. 15 divided by 3 is 5, and 9 divided by 3 is 3. Okay, again, I've got that addition, so I'm going to keep the addition sign. So 3 plus 5 is going to be like my new inside component, because this is a factored version, and these two are going to help me find the GCF. So 2 times 3, just like we did on the last one, is going to become 6. So that's my greatest common factor. GCF equals 6. Okay. Again, we can still factor even if it looks like an expression. So let's do one more. Okay, so let's try 20 plus 12. Again, I'm just going to write it just the same as I have been doing. I'm going to think, okay, what number divides 20 that also divides 12? 2 divides 20 and 12 because they're both even again. So then I do 12 divided by 2, which is 6, and 20 divided by 2, which is 10. Okay. And then I look at 10 and 6 and I say, okay, do they have any common factors? Yeah, 10 and 6 are also even numbers, so they can be divided by 2. So again, I go 6 divided by 2 is 3, and 10 divided by 2 is 5. 5 and 3 are prime numbers, so I'm just going to put the plus sign right in between them. They stay like that. And then I take these two to find the GCF. 2 times 2 is 4, so the GCF is 4. Okay? All right.